Welcome to aminacademy.com. In complex number, let us discuss about algebraic operations with complex numbers. First, addition. If z1 equal to a1 plus b1i and z2 equal a2 plus b2i, then z1 plus z2 equal a1 plus b1i plus a2 plus b2i. Here collect the numbers, that is a1 plus a2 as a real part and b1 plus b2 is the imaginary part. Next one, a negative of a complex number. Here negative of complex number is negative sign of that numbers of both the real and imaginary part, that is minus z equal minus a minus of a plus bi, which is equal minus a minus bi. Now subtraction of the complex numbers. If z1 equal a1 plus b1i and z2 equal a2 plus b2i, then we can write z1 minus z2 is z1 plus of minus z2, which is further equal z1 is a1 plus b1i and additive inverse of z2 is minus z2, that is minus a2 and minus b2i, which is equal, by collecting the real parts, that is a1 minus a2 and plus b1 minus b2i. Next, additive inverse. If z2 equal a2 plus b2i is an additive inverse of z1, that is a1 plus b1i, then z1 plus z2 equal to 0. Therefore additive inverse of z1 is minus z2. That means first write z1 is a1 plus b1i plus a2 plus b2i equals 0. Then here we can write a1 plus b1i equal minus of a2 minus of b2i. Next one, multiplication of a complex number by a constant. If m is an integer and z equal a plus bi is a complex number, then m is z equal, means multiplication of an integer with complex number, that is m into z equal a plus bi, which is equal ma plus mbi. Division of complex number by an integer. Here if m is an integer and z equal a plus bi, then z over m equal z is a plus bi over m. Distribute m for both real and imaginary parts, that is a over m plus b over m I. Next one, multiplication of two complex numbers. If z1 equal a1 plus b1i and z2 equal a2 plus b2i, then z1 into z2 equal, z1 is a1 plus b1i into a2 plus b2i. Then multiplication of a1 into a2 is a1 a2 and a1 b2i plus b1 a2i plus b1 b2i square. further simplification, we can write a1, a2 and I is a common for both, that is a1 b2 plus a2 b1 I. Here the last part is I squared is minus 1, so we can write minus 1 into b1 and b2 is minus b1 b2. Now collecting real parts, a1 a2 minus b1 b2 is the real part, plus a1 b2 plus a2 b1 is an imaginary part of the product of the complex number. Next one, division of two complex numbers. If z1 equal a1 plus b1i, z2 equal a2 plus b2i, then z1 over z2 equal a1 plus b1i over a2 plus b2i. We have to rationalize the denominator. Let us do that one. a1 plus b1i over a2 plus b2i into a2 minus b2i over a2 minus b2i, which is further equal. Denominator have a1 a2 square and b2i minus b2i, that is b2 square I square, means plus b2 square, and top a1 a2 plus minus a1 b2i plus b1 a2i. Last is b1 into b2 is b1 b2, I square is minus 1, that is already minus 4, plus b1 square. Here we can write further a1 a2 then plus a2 b1 minus a1 b2 I plus b1 square over so not b1 square, the last part is b1 b2 square, b1 b2 b1 b2 only. Here b1 b2 over a2 square minus b2 square. Next one, the reciprocal of a complex number. If z1 equal a1 plus b1i, then reciprocal is 1 over z1, that is 1 over a1 plus b1i. Suppose we write that 1 over z1 equal 1 over a1 plus b1i, multiply the numerator and denominator with a1 minus b1i, means that rationalizing the denominator, we can write a1 minus b1i over a1 minus b1i. Here as a denominator a1 squared, directly write b1i minus b1i whole square is minus b1 square, and top 1 into a1 is a1 minus b1i, which is further equal. In simplified form we can write a1 minus b1i over a1 squared minus b1 squared.